Hi everyone. In today's lesson, we're going to talk more about the normal curve. Our goals for today will be to find the mean and standard deviation given data values or percentages. So let's work through example number 1. So it says on a standardized test, Phyllis scored an 84, exactly one standard deviation above the mean. If the standard deviation for the test is 6, what is the mean score? Okay, so as always, whenever I do any normal curve question, I want to make sure I have this picture set up. So I want you to make sure that that's abundantly clear on your papers and that you're drawing the picture every single time. So I'm actually going to set up the picture with the middle value being labeled as 0, which represents my mean, and then 1, 2, and 3, -1, -2, and -3. And these are all of your z-scores. And then I'm going to input the data information. So they tell us that Phyllis scored an 84, which is one standard deviation above the mean. So I can put her data value of 84 right below where it says 1 for the one standard deviation above. And then it tells us that we have a standard deviation of 6. So if you remember from the last video, a standard deviation of 6 means for every one standard deviation I go up, I'm adding 6. And every standard deviation I go down, I'm subtracting 6. So if I start with 84 and add 6, I'll get 90, and that goes for 2. I'll add 6 again, and that's a z-score of 96. And then we're going to start with our z-score of 84, and then to get back to 0, we're going to subtract 6, which will give me 78. Subtract 6 again, I'm at 72. Subtract 6 again, I'm at 66. And then subtract 6 one more time, I'm at 60. So now that we've set up our data values underneath, let's see if we have enough information to answer the question. What is the mean score? Well, I think we do. The mean is at a z-score of 0. So mean is equal to 78. So if it helps, label this with mu. That's my mean, the middle. Perfect. Let's try another example. Okay, so number 2 says, on an English test, Sarah scored a 60, which is exactly 3 standard deviations below the mean. If the mean test score was an 84, what is the standard deviation? So again, just like every problem, I'm going to draw my curve, and I'm going to set it up nicely. So 0, 1, 2, 3, -1, -2, -3, and we can label those with z-scores. And now let's input the information that they tell us. They say that the mean score was an 84. So where the 0 is, I'm going to put 84. And they say that Sarah got a 60, which was 3 standard deviations below the mean. So for -3, I can put 60. And the question is asking us, well, what is the standard deviation? Basically, they're saying, what am I subtracting, not 1, 2, but 3 times to get 60? So you want to look at basically the difference between these two. So if we took 84 and subtracted 60, that should give us 24. So what that tells me is that there's 24 units between these two numbers. But I want to divide it by the amount of spaces that I see. So between 0 and -1 is 1 space, 2 spaces, and 3 spaces. So if you divide it by 3, you should get 8. So by dividing it by those spaces that are in between them, that'll give you the amount of times you're adding and subtracting. So 8 is my standard deviation. So I'm actually going to just erase that, sorry. And I'm going to use the symbol for standard deviation. So sigma x is 8. And let's prove to see that it works. If I'm at 60 and I add 8 to get to the next one, it would be 68. Add 8 one more time, I get 76. And then add 8 one more time, I should get 84. So it works out nicely as I check it out. Perfect. All right, let's try one more example. All right, so for example number 3, I brought back this information that I showed you in yesterday's video. These are definitions. Remember, 68% of the data is within 1 standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. So let's read the example and see how we can use this information to help us. So example number 3, a set of heights of basketball players are normally distributed. If 95% of all of the heights were between 78 and 92, find the mean and standard deviation. Well, again, with every picture, I'm going to set it up. So here's my mean of 0, 1, 2, and 3, -1, -2, and -3. And these are my my z-scores. And let's go ahead and put in our data values. They tell us the key information here that 95% of all of the heights were between 78 and 92. That 95 should ring a bell and draw your attention to this picture right here. So because it says 95%, we're focusing on 2 standard deviations above and 2 standard deviations below. So from here to here is where we're focusing our attention. So 2 standard deviations below, I'm going to put the 78, and 2 standard deviations above, I'm going to put the 92. So these are my data values. So the question is asking, first, what is the mean? Well, the mean is this 0, which is a z-score, but I want the data value. Mean, I want you to think middle, the middle of these two numbers. So if I want to find the mean, all I have to do is take the average. So add them up, 78 plus 92, and divide by 2. So go ahead, type that into your calculator, pause the video, and then hit resume when you're ready for the answer. Okay, I got 85. So that tells me that my mean is 85. Now, just like we did before, we now want to find the standard deviation. So if you look, you could take the standard deviation between these two values, or you could take the standard deviation between these two. So from 85 to 92, we would subtract those, find how many numbers are there, and divide by the number of spaces. So there's 2 spaces here. So for standard deviation, we're going to take the 92, subtract 85. So 92 minus 85, that gives us 7. And we want to divide by the number of spaces. There are 2 spaces, so we're going to divide by 2. So 7 divided by 2 is approximately 3.5. So that would be my standard deviation. The mean is 85 and the standard deviation is 3.5. We could test it out to see if it works. So if I have 85 here and I want to go 1 standard deviation, add 3.5 to that. And that value will give you 88.5. And take this 88.5 and add 3.5, and you should get 92. So that works. That's my standard deviation. Okay, let's try another problem. Okay, so it says that a set of scores with a normal distribution, if approximately 68% of the scores fall between 43 and 57, find the mean and standard deviation. So again, the key word here is 68% of the scores. So you want to focus your attention on this one. 68% of the scores are between 1 and -1. So when we set up our picture, right, the mean is always in the middle. So this is 0, 1, 2, and 3, -1, -2, and -3. I want to be in between 1 and -1 because that's 68% of the scores. So 1 and -1 would be all of this in between here. And they tell you that the heights or scores, are from 43 to 57. So 43 goes in the lower half and 57 goes in the upper half. So again, find the mean and the standard deviation. So to find the mean, we take the average. So add them up and divide by 2. 43 plus 57 divided by 2. And that answer should give you 50. So 50 is your middle, therefore that is your mean. And then standard deviation, I'm going to just use sigma x for standard deviation. Since I'm only at one space over, we really just have to subtract. So 57 minus 50 will give you 7. Or you could do 50 minus 43, and that will also give you 7. So the standard deviation is just the distance between these values. So between 50 and 57, or 50 and 43. Okay, this last one, I'd actually like you guys to try on your own. So this is all the information you need, and then hit resume when you're ready for the answer. Okay, here it is. Okay, so first what I did was I set up my z-scores, and I knew that 99.7% were between 3 standard deviations. So I put the 48.1 at -3 and the 80.5 at +3. To find the mean, you add up the two numbers, average them up, and divide by 2. I added them and got added and divided by 2 and got 64.3. To find the population standard deviation, I subtracted these two values and then divided by the number of spaces. 1, 2, 3. So that's how I did 80.5 minus 64.3 and then divide by 3. You could have also used these two values if you wanted to. So you could have done 64.3 minus 48.1 and divide that by 3, and you should still also get 5.4. All right, so that's it for today. I know it's a lot, but if you have any questions, please let us know and try those problem sets. Have a good night.